Hello guys and welcome to the first course in analog electronics. In this chapter we will try to demystify what voltage, current and resistance is, which are the three fundamental elements that you must know in order to analyze electronic circuits. So we use the term voltage all the time, right? And we know that AA batteries have 1.5 volts, a USB connector or a phone charger provides 5 volts, and when dealing with electronics, we usually work with either 5 volts, 3.3 volts, and sometimes higher numbers. And car appliances, for example, operate on 12 volts, and mains is either 110 or 220 volts. Despite the fact that voltage is everywhere, I often see beginner questions where voltage is confused with current, capacity, or energy. This is not surprising, considering that voltage is often explained with vague terms such as potential difference or electric field or electric tension, which only makes sense if you already come from a physics background. So what exactly is voltage and how does it relate to current? What does ground mean? Can you measure the voltage inside an electrical wire? When giving beginner electronics workshops, I always struggled when I got to the part where I explain about voltage. I spent a lot of time thinking how I can explain it without relying on existing knowledge in electronics. When one day I came up with a simple analogy. Voltage is motivation. It's how motivated electrons are to move from one point in the circuit to another. Amazingly, the first time I tried this explanation in a workshop, one of the students raised his hand and asked, "So is it like when the cost of living in Tel Aviv is higher than the one in Berlin, motivating people to relocate?" At this moment, I knew it clicked. The more expensive Tel Aviv is relative to Berlin, people are more motivated to move. Their level of motivation is the voltage. Relocating, however, is not trivial. You have to pay for the flights. So if the flights are expensive, only the most motivated people will travel, but if the flights are cheap, the amount of people traveling will increase. So the cost of flights is the equivalent of electrical resistance, and the actual number of people moving from Tel Aviv to Berlin every day resembles current. Alright, so again, voltage is how motivated are electrons to move from one point to another. Resistance is how hard is the way between these two points, and current is how many electrons actually travel through a specific wire every second. This relation between these three is defined in a very simple formula called Ohm's law, which states that voltage is equal to current times resistance. This is the fundamental thing you need to know when you try to make sense of electronic circuits. In fact, we will learn about Ohm's law in more detail in another course, but you have to know right now that many of the rules can be easily derived once you understand this fundamental relation. Now, when you have a power source, such as a battery, it has two leads, right? The positive and the negative. When these leads are disconnected from each other, there is no route for the electricity to flow, so the resistance is infinite. This means that there will be no current, just like if there are no flights between Tel Aviv and Berlin. Even with the highest motivation, it won't be possible to make this journey. Similarly, if we short-circuit the battery, which means that we simply connect the positive and the negative terminal together with a simple wire, there will be a nearly zero resistance path between them, which means a lot of current will flow. This is similar to having many airplanes or very large airplanes going between Tel Aviv and Berlin, driving the airfare very low. Even with the slightest motivation, you will still jump on a plane and make the trip. Now, when we connect a resistor between the leads, we can apply Ohm's law to figure out the current. Let's try it with some numbers. Assume we have a 1.5 volts battery and a 100 ohm resistor. What would the current be? So using this equation, we get 1.5 equal to current times 100. So the current equals to 0.015 ampere. That's 50 milliamps. What happens when we connect another 100 ohm resistor in parallel with the first one? We can use Ohm's formula again, but let's try to understand it intuitively instead. By adding a second resistor in parallel, we just added another path through which electrons can flow. It's basically as we added another daily flight between Tel Aviv and Berlin, or made our airplane twice as large. This means that we can now drop prices. In other words, the resistance has decreased, so despite having the same level of motivation, more people can now travel and the current will increase. In contrast, adding a resistor in series is like stopping the direct flight service to Berlin, so you now have to take a connection flight, for instance to London. This means the prices will go up, as now you have to pay for 2 flights instead of just 1. So the resistance has increased, less people will be willing to pay for traveling, and the current will decrease.